All right, good evening, everybody. Welcome to FOP class uh, 8, 4, 5, 7. Class 7. You lose track, man. Especially when you start with index 0. I don't know why I was messing me up. Uh, but yeah, welcome. Hopefully you guys were able to have a good night's rest and take in all the information from yesterday, created some flashcards and did some studying. We're gonna go ahead and pick up from where we left off yesterday. But before we start the lesson, does anybody have any questions about what was covered yesterday or anything up to this point? The time to ask is now before I add up more stuff into it. Okay. Let me go ahead and share my screen. Yesterday we finished off talking about nested loops. Um, just kind of to reiterate a little bit about it. Whenever you put a for loop within a for loop, that nested for loop, right? The second one that you guys create within that for loop, that's going to reiterate. Um, Typically they tend to use it to reiterate on what they use on the outer for loop, right? And we saw that here happen whenever we looped through the list of animals. We grabbed the animal and then we did something with the animal, which was looping through each individual letter. Uh, it's not the most ideal to have nested upon nested for loops, but sometimes you do need to use nested for loops, and it can come very handy. I know probably every single one of you guys had some kind of nested for loop in your application, or your challenges. I just know it. Um, Next, we're gonna start off today's with a assignment. All right, it's gonna be the number guess dot py. So we can go ahead and open that up. That's my answer key. Okay, so we had the number guess.py. It shouldn't have anything within your Python file. But go to README. It's gonna give you the instructions. Your task is to write a program that prompts the user for an integer that the player will try to guess. Recall from yesterday's class, requesting input from the user using the input method. And then assigning whatever input's given to the console into a variable. If the player's guess is higher than the target integer, the program should display too high. If the user's guess is lower than the target integer, the program should display too low. The program should use a loop that repeats until the user correctly guesses the integer. Then the program should print how many guesses it took. When you run your program, it should match the following format. Right, we see our initial input prompting us for some kind of number. They give it -12, or the number is supposed to be -12. The guess was 100. It tells it too high, try again. They enter 50, and then it gives them too high, try again, so on and so forth until they get to -12, and then you guess it in 4 tries, right? If the user guesses the integer in 1 try, then your program should print you guessed it in 1 try. Now, obviously, there's gonna have to be some kind of loop with a condition. That condition being whether uh, the guess was correct or not, and it's gonna keep running until that guess turns correct. I can already think of different ways of doing it. Maybe starting a while loop, creating a variable that is a Boolean that can start off as false, right? That Boolean could be like guess correct, and then you can say, while guess correct is false, then run this for loop, and you can run that for loop until you get the designated guess. All right. So I'll give you guys 15 minutes to kind of start off on that, and then we kind of code along, make sure everyone understands the assignment. And let's jump straight to it. I'm sure some of you guys did it using the random module, right? Even though we haven't taught importing modules on Python, but that's okay. I like the enthusiasm. All right, so disclaimer, I don't like to lie about stuff. I am using my notes, so I do have the assignment already completed, so I'm just using my my completed assignment so I can kind of code from there. So we're gonna go ahead and start our number gets.py. And as you recall, we talked about the for loop, right? And also creating a variable that either tells you whether you won or you have not won yet. So we can go ahead and create that variable now, and we can just call it one, as in WON, and set that bad boy to false. And this is what we're going to use to track and to use as a condition whether we have completed the game successfully or we still need to make guesses. Next, I'm going to create another variable, which is going to be tries, and I'm going to start it at 1. And tries will keep track of how many times somebody has guessed throughout the game. So these two variables will allow me to keep track of the progress as well as when to stop my while loop. And I'm going to start my while loop by saying while 1 is equal to false, then I want to do the following code, right? So this loop will keep running until I change the Boolean to true, right? Now, once this while loop starts, I'm going to prompt the user with my question. And I'm going to save it to a variable called player guess, right? The input method will allow me to prompt them for a guess, and then I will give them the message, which is enter your guess. And then, as you recall from yesterday's assignment, we had the integer wrap around what comes back from input to ensure they don't give us some weird kind of response, right? So once we receive the guess from the user, we can move forward and check whether the guess was correct to the number we wanted or if it wasn't. Now, we can manually put in a number here and just be like, set the default number for this game to like 5 to see, that's going to be the correct number. Or we can make it a little bit more interesting, right? We can use a random module, which some of you guys probably found out, and we can import it. Python has a bunch of modules that come with it that are already kind of built for Python. All you have to do is import it directly to the file that you're using. And to import it, it's as simple as typing in import at the very top of your file, and then the name of the module you're using, right? The module we are using is going to be the random module. And then we kind of see how that works in Python random module. We can see here in the Python docs, or you can see in W3 schools. I feel like W3 schools is a little bit more user-friendly to kind of look at. So we'll come here. And we see here on the module reference, the overall documentation for random, right? So this is how random is spelled out on Python, how it's imported, right? The how it's typed, all lowercase, and then we see the different methods that come with random. And you can kind of filter through these and check out which one fits what you're trying to use. What we are going to use is going to be randint, right, for random integer, which returns a random number between the given range. So we can go ahead, click this method, and we see here an example of how it works. We have the import statement at the very top, and then the way that they use the random integer is they call the module random, and then they use the randint method. So random.randint, right? Open and close parentheses, and they give it a range, right? So return a number between 3 and 9. And we can kind of see that ourselves. If we press try it yourself, it gives us 5, and we can keep running it, and it should give us a different number every single time we run it. We get 8. Now, I don't recall if it includes the 3 or not. It does. It includes the 3. I don't think it's going to include the 9, though. I think it includes the 3, but it's only up to 9, not 9 included. Oh, it is. My bad. Here it tells you both included. So it is both included. And the reason I bring that up is because when you guys use stuff like range, right? Typically that second number you guys give it, which is the range between what that number should be, it's up to but not including the second number. But I guess the random method does include both numbers. Right. So let's go ahead and move forward. So I'm going to go import random at the very top. And then along with my other variables, I'm going to create a new one, which is going to be correct number. And then I'm going to use random.randInt. And then I'm going to start at 1, right? Because it includes both numbers. And I'm going to set this bad boy to 20, right? Just for demonstration purposes, we'll keep it short. So that's going to be the correct number. Now, we can actually use this now within our while loop. So we take the guess from the user, and then we're going to compare the guess to our correct number. So if the player guess is equal to correct number, then I want to do something, right? I want to stop the game because that means they guessed correctly. If tries is greater than 1, right? If tries is greater than 1, then we're going to do one thing. If not, then we're going to return you completed it in one try, because these are going to be two different responses. Well, why? Well, because once you get to 2, the response should say something like you guessed it in 2 tries, right? But if it was in 1 try, it should be you guessed it in 1 try, right? So plural versus singular, right? So we want to have 2 different messages that will return depending whether it was on the first try or whether it was on multiple tries. So if tries is greater than 1, then I want to print out you guessed it in, we open do curly brackets, we put tries in here for the variable, and then the string tries. So they should return you guessed it in 4 tries, 5 tries, 6 tries, whatever it may be. Now, in the event that it's not greater than 1, then we're going to do an else statement, which is going to be else print you guessed it in 1 try. All right, so we have a plural version and a singular version for it. So that takes care of whether it is correct. Now we'll do we'll go back to the outer if statement on line 9, and we'll add an else if, right? So this is how you do else if. So other options within your if else statements, if you have multiple different things that might happen. So else if player guess is greater than correct number, then we should, for 1, we need to increase the tries to 1 because they wasted a try. That means they haven't finished the game and they're going to have to reloop. But after we increase the tries, we also want to print out whether it was too high or too low. In this situation, it was too high. Try again. Right? So if it's not correct, if it's not less, I'm sorry, if it's not correct or if it's not more, then it should increase our tries by 1 again, as well as printing too low. Actually, I'll do an else if as well here in case it adds some weird stuff here like strings or whatever. We can kind of add more case statements here to kind of filter out wrong input. So we'll just do an elif statement. So we'll do elif player guess is less than correct number, then tries equals plus equals 1, and then print out too low, try again. Now we can go to our number guess folder and run our number guess file. And we see here in our console, enter your guess. I'm gonna add 5, too high, try again. I'm gonna do 2, too high, try again, add 1. You guessed it in 3 tries. But what happened? It's still prompting me for input, right? So something's wrong here. What did we not do?
Set the while loop to true when you won.
Correct. We didn't add the statement to close off our while loop. Our while loop is still running, right? It is to keep running because we never set a condition to stop this while loop. So we go back to the win statement, right? On the if player is equal to the correct number. And then after the if else statement for checking whether it was high or low, we're gonna do 1 equals true. right? Let's go do Control C to stop our program, run it again. Let's go with 5 again, too low, try again. Let's go with 15. Oh, I got it right. You guessed it in 2 tries, and my program stops running. Cool. Awesome. Uh, okay. Now, let's go ahead and move forward. Does anybody have any questions about the assignment? Does this make sense to you guys? Did someone do it similar to how I did it too? Or did you guys all use a manual number?
I used a manual number, and then after I got at work and I used the random.
Okay. Yeah, I figured most of you guys probably start off like that too. That's good. All right, let's go ahead and move forward with our lecture. So that takes care of the number guess.py. Python functions, right? Python functions. Now we get to the real reason why people code, right? Functions is, the biggest part of coding. It's what really makes it. You can't really do too much without functions. So when programs get longer and logic becomes more complicated, it becomes harder to keep track of everything, right? Functions are used to manage complexity and increase reusability. Each function should really be in charge of doing one thing. Here we have an example of how the functions are created. So in JavaScript, you have been used to typing in function to create your function. Here, the way that it's used is by def, as in define, right? So define sum underscore 2, and then it takes 2 parameters, right? Num1 and num2, and then it uses those within the function. We see here total is equal to whatever num1 and plus num2 is. Never return the total. Notice that we are returning stuff. So once a function is complete, if you want to have access to what's inside a function, you have to return it. And then we call the function on line 5. Sum2, they pass in the 2 and 5 in there, and they print it out on line 6. And we see here in our console the response of what our function did, right? Pretty straightforward. It's still very similar to how you would in JavaScript. 2 biggest things is honestly just the way we declare it. We don't use function to declare it. We use def. And then notice that we don't use open curly brackets either. It's just a colon, and then you can go straight into your code. All right, so no curly brackets needed. How do you know where your function is? Like, well, I use the curly brackets. It tells me where my code starts and ends. Well, we use the indentions, right? So everything so once the function starts on line 1 here, everything that's actually within the code block for our function, it's indented once. And we see that here on line 2 and 3. Once the function is complete, right, like where it should supposed to be ending, we see here on line 5, it's back to its normal spacing. So that's how you identify where your function starts and ends, right? You don't necessarily need your curly brackets. The indentation is what really matters. Function scope, right? Variables in a function only exist while that function is executing, right? In this code snippet here, we created a function called test. They created a variable num and assigned it the integer 12, and then we return num. And we get an error here, right? When we try to do print num, we can't print num, right? Why is that? Well, because we defined the function, but on line 5, we're not running that function. We're trying to call a variable that was declared in a function. Think of functions as almost like a blueprint, right? A recipe to do something, right? Instructions, right? That's what the actual build of the function is. This is instructions, right? If you have a recipe that tells you you need a cup of milk, right? And then you try to magically use a cup of milk, just because the recipe says that you need a cup of milk doesn't mean you just magically make milk. Where's that milk going to come from, right? So you can't use stuff that's out of there. You actually have to you know use the recipe and actively go through the process of making it. You can't just pull stuff out of thin air. Same concept with the variable. We created this uh this number here, this variable within that function. So once it was outside of the code block of the test function, we weren't able to use it. How could we use it? If I wanted to use what num is, how could I use it?
You could make it global,
Sure, but
or
Put
not.
it inside the. You can put it inside the function.
I could use it in the function, yes, right. But the reason why it's not being used, if we go to where's my example? Here we go. Right, we had define. It's called test, open and close parentheses, and then they have num equals 12. And they do return num. They try to print num directly, and they couldn't. Right, they get an error. Right, name num is not defined. Did you mean some? All right, it's trying to correct you to see what it is. Obviously, it's wrong. But the way that you would actually have to get num out of this function is you have to actually use the function, right? You'd have to call test, right? Because we see here on line 3, we're returning it, right? So what happens is when you use that function that has a return statement in there, right? It's going to run the code of the function, and at the very end, once it gets to the return statement, it's going to send it back to wherever it's being called, right? We're calling it here on line 5. Right, test is being ran here. So once test runs, num is sent back into this line, and it takes the placeholder of whatever test was. So essentially, what ends up being here is what num is, because that's what we're returning. So by doing this, we see here that it prints 12. It actually gives us access to the num, right? What if we don't return anything? What happens then? And we try to run that function. You're gonna get none, because there's nothing being returned by this function, right? Nothing being returned by this function, so therefore we never get access to num. So you have to have return if you actually want to use something that comes out of that function. So return num will allow us to actually receive that 12 back. Yes, Mike, we could obviously create the variable outside of the function if we want to use that variable. You're absolutely correct, right? But if this situation was that this function is what's going to create this variable, like we have to have it within this function. How do we get it out of there? Well, you have to return it, and you have to actually call the function itself. We can, instead of doing print here, we can just call test so it runs, and then within the function we can print num, right? And then we can do this. This function, all it does is create a variable and it prints something for us. So whenever we run it, it'll print it for us in our console. But what if, if we don't have the return statement, even though it's printing num, we still don't have access to it. What if I create a number variable, I assign the function to the variable? What if I could do that and I run it? Right, we see the 12 is still printed out because that's what the function is doing. But what if we try to print out a number? It's never going to work. It's not going to work because what did we remove from this function?
the return statement.
The return, right? So sure, the definition of the function within this function, we're actually printing out what num is. But if we try to assign the something to a variable, right? If we try to assign this function to a variable, this function won't return anything. So if we try to use it in this manner, we won't be able to have anything saved into it because it did not return anything. But if we return num, both the function itself being ran will print number, and also line 8 will print number because we're returning it. And we get 12, 12. Cool? Awesome. Default arguments. it is possible to give a parameter a default value if no argument is passed in for it in the function call, right? So we see here we have a sum function. We have num1, but num2, we assign it a value, right? Num1, comma, num2 equal to 10, right? And then we return num1 plus num2. What happens here, on line 4, we give it the number 5. Even though the function has a default value of 10, because we passed in a new value in line 4 when we call it, that 5 trumps what was the default, right? A default is set in the event that you don't want to add an additional argument in there. And you can still call it, like we see here on line 5. We do sum2. That 2 takes the placement of where num1 is, and they don't add a second argument because it's already preset within the actual definition of this function, right? We gave that default of 10. So therefore, 5 returns to us 12, right? 2 plus 10, which was the default, 12. On line 4, it returns to a 7 because we gave it that second value. We're overriding the default value of num2, right? So you can use it either way, but you could preset a default in the event you want to use it without always having to give it that parameter. Maybe it's an optional thing, right? And what's an example of that? What can I use as an example? Okay. Let's go with define. We'll call it creature. And then we'll give it a name, age, and we'll give it a species. Our default is going to be a string called human, right? Because typically, we have more humans than pretty much most animals, right? And then we can create our variable, right? Whatever is passed to name, it will be like name is equal to name, age is equal to age, species is equal to species, print name, age, and then species, right? And then we can do creature passing James. I'm gonna take a wild guess here, James. 28. And then we don't give it a default. But this new creature we're gonna create, we're gonna call this Oliver. This is my dog. Oliver, he just turned 1 8 days ago. And the species is going to be dog, right? Our default is human because we're creating multiple humans in this scenario, but there's one situation we're creating a different dog or a different creature, and this one is a dog, right? So we have to give it a different one. But because most of the things that we were creating, right? Let's say we're creating our own world and we're populating it. We create James. We know he's a human, so I don't have to add a default. But when I finally decide to add dogs into the world, I have to give it a new species name, right? And this is where this comes in handy. Cool. All right, moving on. Doc strings, right? A doc string is a special type of string you should use to help document your functions. This doc string should give a description of the function purpose, all right? So use triple quotation marks like the example below. There's different ways to comment these stuff out. What this allows you to do, if I'm correct, it allows you to comment out on multiple lines. But it is used very commonly to document what your code is doing, right? When you guys start working with real world code in different environments, hopefully the code base is documented, which will make it easier for you guys. It's very common that it's not properly documented. So you may be required to kind of go through the code and kind of make sense of what is happening on the code. And it's not uncommon for interviewers to give you a piece of their own code that they're probably using and to tell me what's happening here. And then you having to interpret what their code is doing. But yeah, so docstring allows you to kind of add some comments into your functions where you think something is important for a other developer to know, so they understand what's happening within this function. Along with docstrings is also the naming conventions of your functions, right? Don't just name it something stupid, right? Right? Somewhat. What are we summing up? Right, we're summing up, the amount of people who register for our website, right, or whatever. Some of new users, you want to be descriptive with what you're naming your functions, and start doing that now, right? So it becomes a habit. If you guys get lazy and you're just naming stuff like function 1, function 2, I've seen it, right? You're going to have a very tough time, and on top of that, we're going to have a very tough time trying to help you out. So on top of functions, everything that you name, whether it's variables as well, proper naming conventions. Also, the way that we name stuff, you've probably already seen it, right? Look at this function. What strikes you, of being weird from the way that this is named? For my JavaScript users who've been coding in JavaScript, what's different? Correct.
Snake case.
Snake case. Yes, snake case. Good stuff, McLean. Snake case, right? We see here Python typically, right? It's what's supposed to be like what most people do, right? You do like after every word you put an underscore. It's not mandatory, right? Not everybody does it either. You guys have used camel case for the most part in JavaScript. That's kind of the standard of how people code in JavaScript. Don't get pressured or feel like you're messing up because you're not using camel case or snake case. At the end of the day, it's going to come down to what the pretty much SOP, right, of where you're working at is, right, of how they code in their naming conventions, right? You pretty much have to follow what they do. But don't feel like you have to switch over every single time. Just know that this is a way of how the stuff is coded. Cool. I'm really bad with reading the chat, guys. So if you guys talking in the chat, what you call it? You guys have any questions? Stop me in my tracks. I saw Brandon. Welcome, Brandon. Good to have you back. And I see a lot more people today than we had yesterday. I'm glad you guys are returning to the call. I do have to send a report about how many people actually make it through. Not to say that any of you guys are going to fail or not make it through, but for statistics, just to make sure we know like how many people actually came through to most of the classes. At least 75% is what we're striving for. But yeah, so just know that that's the thing. Cool. All right, next one. I hate this one. I'm not even gonna lie to you. I have to look this up every single time. All right, Hailstone.py. All right, so you're gonna write a function called Hailstone that takes an integer and 1 and prints the Hailstone sequence. All right, this sequence takes the name Hailstone as the number is generated, bounce up and down. To generate the sequence, follow these rules. If the number is odd, multiply by 3 and add 1. If the number is even, divide by 2. Repeat until you reach number 1. Right? Let's check out the document. Is this the one I hate the most? There's another one that I hate. I don't know. I don't know what that. All right, Hailstone. So empty code block. So a Hailstone sequence starts with some positive integer. If that integer is even, then you divide it by 2 to get the next integer in the sequence. I'm gonna save you guys time of reading you the instruction of what Hailstone is. Write a function named Hailstone that takes a positive integer parameter, right, as the initial number of a Hailstone sequence and returns how many steps it takes to reach 1. Technically you could keep going, yada yada, but you will stop when you first reach 1. Right? If the start integer is 1, the return value should be 0, since it takes no steps to reach 1. For example, if the start integer is 3, then the sequence should go 3, 10, 5, 16, 8, 4, 2, 1, and the return value should be 7, since it took 7 steps, right, to reach 1 the first time. Your function that does not need to print anything out, just return a value. All right, and here we see the example of how it should work. Answer is equal to Healthstone 1000, and then print answer. Right. Notice that this is the actual function call. They're calling the function here. They're adding the number within the function as an argument, and then once the function runs, it saves the value into the answer and then it prints it out. You cannot use recursion. We have not talked about it yet, so don't use recursion. Since we haven't covered that technique, that means that for this time, you cannot have your function call itself. This includes indirect recursion, such as function calling a second function that calls the first function. All right, so no recursion for you tryhards, Justin. Cool. We will give this 15 minutes, so you guys got to 6:30. Upon 6:30 hitting, you guys are welcome to go to break on your own, and then we will start this at 6:40. All right, give it a try. Let's go ahead and come back to the class. We had a couple people drop. That's unfortunate. But I know some people messaged me saying they have to go and do stuff. We're gonna go ahead and continue with today's lesson. We are covering Healthstone.py. Were you guys able to complete it?
Yes.
Awesome. Let's go ahead and do a walkthrough of that Healthstone.py. Let's put my screen. Okay, so we want to create a function called Healthstone. And then it's gonna take a starting number. We'll just call it initial number as our argument. And then we're gonna declare a variable called steps, and this is gonna allow us to keep track of how many steps we've gone through until we reach 1, right? So it's supposed to take a positive integer parameter as the initial number of a Healthstone sequence and returns how many steps it takes to reach 1. So once we get our steps, we're gonna start a while loop. And this while loop is going to be while initial number does not equal 1. We're gonna want to run this loop, right? Until it reaches 1, and then we can just grab how many steps it took to get to that point, right? So essentially now we just got to do if else statements and check the different types of conditions that are given to us in the Healthstone sequence, right? If the string integer is 1, the return value should be 0, since it takes no steps to reach 1. Where are we there? For example, where's the example? Okay. If that integer is even, then you divide it by 2 to get the next integer in the sequence, right? So if the number is even, well, how do we check if something is even? So if you guys recall from yesterday's conversation, we do have access to the modulus operator, right? And that gives us a remainder of what's left after we divide something by a number. So we can do if initial number modulus 2 is equal to 0, that means that, for example, if the number was 10, we do modulus 2, it should return 0 because there is nothing remaining, right? Because 10 was an even number and it was evenly divided by 2 5 different times, giving us a remainder of 0. So if the initial number modulus 2 is equal to 0, then we want to do something, right? And that's going to be, what was it? We divide it by 2 to get the next integer. Okay, so then we would do initial number, and we can do divide equals, right? Essentially what we're doing here is we're dividing it by 2 and saving it into our initial number variable. And the divide equals is similar to the plus equals. It's doing the exact same thing, but we're using the divide method on it. Notice it's 2 forward slashes, therefore the floor division. So it'll round down, and we'll divide that by 2. Now, in the event that it's not even, what do we have to do, right? If it is odd, then we have to multiply it by 3 and add 1 to get the next integer in the sequence, right? So if it's not even, it can only be one other thing, which is going to be odd, right? So else initial number is equal to 3 multiplied by initial number plus 1. We didn't do something like this, right? Because we had to do the plus 1 as well. So we just went ahead and just did the actual math itself. 3 times the initial number plus 1. And then after we do one or the other, whether it's odd or even, what do we have to do? We have to increase our steps by 1, right? Now, it's going to keep doing that until our number is equal to 1. Once this for loop is complete, we need to return from this function and get back what our steps were. And we should be able to do answer is equal to hailstone. We can give it an example here like 3 and print out answer. And let's see how that works. CD hailstone Python open.py. All right. And it gives us 7 steps. We can print it out if you guys would like. We can say do print initial number on each step so we can see how that works, right? So this is what was being printed out. The final answer was 7. So 1, 2, 3, 4, 5, 6, 7. That's what it took, right? The first time we got 10, then went to 5, then 16, 8, 4, 2, 1, eventually giving us the total of 7 steps. So we're able to visualize it and see that it was actually doing what it should be doing. All right. I'm wondering, what is the 1,000 going to give to us? 111. That's cool. Awesome. Pretty straightforward, guys.
Don't forget to account for if you get 1 right off the bat.
Yeah, we could do 1, right? So if initial number is, equal to 1, we can just say return right here, right? Return with what? With 0? Return 0. So we could do the edge cases. Thank you, McLean, for that. You would do that before you even start the while loop, because what happens here, if it does equal 1, it won't even get to line 5 because it's going to leave the function. It's going to return. The function stops right there, right? So we would do that before that, right? Awesome. Thank you for that. All right, let's go ahead and move forward. Let me share the next part of the assignment. All right, so that covers the hailstone.py. Next thing is going to be our list, and we kind of already saw a little bit of that earlier. Let me go ahead and go to my practice file so we can kind of code along. I hope you guys are making like notes or the Anki decks to kind of code along. It'll pay off in the long run. All right, so next thing is gonna be lists, right? What are lists, right? So essentially a list is a mutable data structure that have an ordered sequence of elements. What does mutable mean?
It can be manipulated.
I'm looking. I mean, yes, it could be manipulated. I would use a different word. It could be changed, right? It can be changed. So you can change the data type and add different things or remove things, right? It's mutable. Then we have other data types that are not mutable. Who knows one of them? The very common one.
Tuples?
Tuples, yes, that is one. That's gonna be next within the slide. Tuples is an immutable data type, correct. Strings are essentially immutable as well. Like, your variables, when you create a variable and assign a string to it, and then you reassign it a string as well, like a different string, that variable is immutable. You think you're changing that variable, that string, you're not. You're recreating another one in memory. But lists are a mutable data structure that has an order sequence of elements, right? And as you guys all may know, up to this point, zero index is how we count lists, right? Just like we do arrays. Strings also are counted using the zero index. Getting the elements from the list is the same as JavaScript using what we call bracket notation, right? So if we had a list of animals like we had before, we had our dog, our cat, and our bird. If we wanted to grab the first item in here, we use animal list, open and close brackets. We would do 0, right? Because we said that index starts at 0. And then we can print out, we should be able to run the code and it prints out dog, right? We use bracket notation. Cool. We can have lists of different data types, right? So we have different data, we'll say number, yeah, data type, whatever, right? And this will be a string. We will have an integer. We will have a float. And then we can even have a list of lists. Yeah, this list will be, I think that's a hard coded list in here, actually. Actually, I should be able to do animal list. I can add animal list in here, the variable that we just created. And we can even do dictionary example. Dictionaries are instantiated with curly brackets. We'll talk about that later. Right. And we can do for item in different data types, print type item. Right. So I'm gonna print each item. And we're gonna see the different types that we get. And you see here we have a string, integer, float, list, and dictionary. Right. So we can have different data types within our list. We have a list within a list, a dictionary within this list. And that's the cool thing about lists. Slicing a list, right? So slicing a list. Slicing a string gives you back part of that string based on the indices for the start and end you have written, right? A simple way to remember it, I don't know why I say string. It's using string as an example, but we'll use list and then we can use strings as an example. So this is gonna be my number list is equal to 13, 20, 53, whatever. Right. Now, to slice a list, to grab a partial portion of your list, you use bracket notation as well, but you use your colon to give you your start and end points, right? And we see the example here. They have like array, and then we have the open and close curly bracket, open and close brackets, and we have different sections to this bracket. If you were to put just one item within this bracket, right, that would tell, or that it's explaining, or what's the word I'm looking for? Signifying that this is just the start, right? If there's only one thing in there, the very first item that you have in your bracket, that's just the start of where you want to grab something, right? So if I were just to have array 0, then I'm just going to bring back one item, which is going to be at index 0. But you're able to add multiple different arguments within these brackets. You could do stop and step. Essentially, by doing number list, I can show you. By doing, let's say 1. On line 4, by doing number list bracket 1 bracket, that would return to me what's in index 1. But what if I do number list bracket colon 3? What that's going to do is going to return to me the items within this list that starts at index 1 and goes up to, but not including index 3. right? And we can print this out to demonstrate how slicing works. Right. Here, this gives us the item at index 1, which is 53. We see it printed out here. But here we're grabbing the item between index 1 and index 3. Notice that index 1 is 53, right? It is at index 1, and we get that as our first item. So the first item will give you that number, right? But what is index 3? 0, 1, 2, 3. Index 3 is 96, but it only gave us up to 23, right? It gave us only the 53 and 23, but not 96. So keep in mind that the stop does not include that number. It'll give you up to that number, but not the number itself, right? So this is how you slice between a start and an endpoint on your list. And then you have we have the step. So what is step? Best way I can explain it would be by doing something like this. I'm going to create the alphabet here for you. It's a list of strings. Actually, I'll keep it simple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I am going to start at index 0. I'm going to stop at index, what is this, 9? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. I'm sorry. I count like a second grader. But yeah, so we got up to index 1. By adding that third item here after the second colon, we're telling it to do something specific, right? Step. If we run it, you're gonna notice that it goes from number 1, which was our start point, and then it goes to number 3. Why is that? Well, because we added the parameter on the step section, right, which is 2. And what that's telling it to do is I want you to step over 2 numbers, right? So it's every other 2 numbers. So it goes to 1, and then it goes to 2, 3, right? So essentially skips over the first one and goes to the second one. Make sense? If I did 1, it won't change anything, right? So step really only works once you go to increment to 2. We see -1, we see 1, it goes to 3, it goes to 5, goes to 7, and up to 9. So step allows you to step over a certain amount of indexes. Now, something cool that we can do. We can just go ahead, remove the 0, and we can remove the 9. Essentially, we don't give it a start, and we don't give it an endpoint, but we give it step. It still does the exact same thing for us, right? Starts at 1, skips over a number, it goes to the second number, so it can be the 3, goes to the second number, goes to 5, second number, which is 7, second number, which is 9. We don't give it a start or an endpoint. It'll go through the start to the end because nothing was given. So the default would just be, from start to finish, but we're stepping over every 2 numbers. Now, what if we make this number 1? It goes back to normal, 1 through 10, but now we're going to add a negative. If we use minus, what that's going to do is going to give you your list backwards. It's going to give you your list backwards. It's going to step over a number 1 at a time backwards. And this gets very interesting when you start working with strings. I'm sure as a beginner, you guys seen stuff like reverse this string, right? Reverse this string. Well, you will come to find out that by using the slicing method, by using an colon, -1, you're able to reverse a string in just 1 line of code. Right. So right now, what we were doing is we were looping through, or essentially we were slicing through an actual list. But what if we change this to a string? So you say string example is equal to, we'll say dictionary, right? Because I can't think of a much longer word. We'll use dictionary. We can slice through a dictionary the same manner that we slice through the list. We can say string print string example, and then we'll start at index 1, and let's go up to index 5. And notice that it'll give to us ICTI, right? I being that index 1, and it goes up to, but not including index 5. All right, so we're able to slice a string using the bracket notation. If we go to our bracket and add colon, colon 1, it'll go from the start to the end, stepping over it once. It'll give us the entire string. And now that we add that negative in here, it'll reverse our string for us. So all these little basic challenges that you guys did where you're like looping through these strings, trying to figure out the last letter, try to, you know, reverse it, you're able to do that on one line right here using bracket, sorry, not bracket, using colon, colon, negative 1. Make sense to you guys? Nice little neat trick. It's nothing major. I just, you know, many people get confused with that third one, which is a step, and what it is doing. It's just, you know, how many times you want to step over something. By just leaving it at 1, you keep it at its normal order, which is just, you know, going in order by ones. And then adding that negative allows you to reverse the process. All right. Wait till you find out it's way easier to capitalize your first letter of every word. Yes, it is. All right. So moving on, guys. That's slicing list. Operators for lists and strings. The operators that we're going to talk about is, if you guys are following along in your slides, is we have in and not in. All right, checks if a value is in the string or in a list, right? So essentially what you would do is if you had a list of numbers, so numbers, it would have 1, 2, 3, 4. And we could say if 7 in numbers, print it's in here. And we see nothing is printing out here. So let's add an else statement. Else, in case it's not in there, else print it's not in here, right? Obviously it's not in there, right? So it's not gonna pass that. But let's say we change this to 2, run that bad boy. It says it's in here. We're able to check if something is within the list by using the in operator. Or we could say if 7 not in numbers, it's not in here, and change this to in here. And it'll check if something is not in there. Right, so using the in and not in operators will allow you to check stuff within your list. Same thing with your strings, right? So we can just say make this dictionary. If K not in numbers, say it's not in here, so on and so forth, right? And we see here it's not in there, all right? But what if we change this to whoa, if I not in numbers, but it isn't. Am I doing something wrong? Dictionary. I'm pretty sure I did this right. What am I doing? Why is it not giving me what I should be getting? There we go. Stupid code. I was confused. These didn't want to run it right. But there we go. It's in here. So it's working. Sometimes you just have to run it again. Kind of like when your TV stopped working, so you just gotta smack it on the side. All right. So the in and not in. There's something about it though. It looks convenient, right? And something that's gonna come into play later on, which we're not really talking about right now. But is it? Am I sharing? I can't see my screen.
You are.
Okay. The in and not in. How is that working? How is it working under the hood? It's essentially a for loop, right? It's essentially a for loop. So whenever you use the in or not in operator, what your computer is doing, right? What the computer is doing in the background is it is going through every single item within your list and checking if that item matches what you're trying to check if it's in there or not. And I say that now because once we get into time complexity and space complexity, that's gonna matter, right? When we talk about if something is like if if that's fast, time complexity doesn't take too many steps, or if it takes multiple steps to process something or to do something, in and not in are doing things under the hood that are essentially a for loop. And why do I say that? Well, because when it comes to how effective your code is, it is measured in the time complexity, which is steps, which right now is out of the scope of today's subject. Just know that all these nice little methods that you guys are using, the operators, it's not just magic. The computer actually has to do some steps behind the hood. You just don't see it. And I just want you to keep that in mind. So once we get into time complexity, you understand like why that matters, right? So just know this is one of the examples, like an in, not in, and how that's doing. Justin, why are you trying to take a picture of me, weirdo? All right, just take a screenshot, bro. All right, so in and not in, it checks if value is in a string or list. The next one's gonna be find, right? So find will return the index of said element or -1 if it's not found, right? So the example we have here, our slide is animal is equal to anteater. And then we do print animal dot find, and we're gonna try to find the letter N. And notice that we get a 1, right? It returns the index because N is at 1. And what if we do something like E? It gives us 3, right? It checks the index of the first E. So 0, 1, 2, 3. It grabs this one. Notice that we have an additional E. It's not going to return to you the indexes of all the E's. Find will grab you the very first one that it encounters, right? So just be aware that that's how that works. And then you add a letter or element that you're trying to get, and it's not in there, it will tell you -1, right? So find is a nice little method. I haven't really had to use find ever, but just know it's one of the methods you can use or operators for your list. The next one, which is actually one that you will probably use a lot in your career, it's gonna be length, right? Length, right? So right now we have the animal. We can print out the length of a string by doing len, opening close parentheses, and adding animal into it. We see here we get 8, being 1, 2, 3, 4, 5, 6, 7, 8 letters. Notice that it's not counting by index; it's by actually the quantity of letters that there's in there. And I say that because that's important. Especially when you guys go and you start doing like for a range of the length of a list or a length of a string, right? You might want to have to set the start point at 0. You have to do like in the range of 0 and length of whatever your element is. If you want to start grabbing stuff from index 0, if you're gonna be doing that in that manner, so keep that in the back of your head. All right, so length lets us get the length of our strings as well as the length of our list. Right, I'll keep it simple. Three items within our list. So length, same thing as dot length as you guys use and are more common, more aware of or familiar with in JavaScript. Next, min, max, sort, and sorted. Some other built-in methods that you can use in Python. Something you guys will probably be using a lot as well. So min and max are built-in Python functions, right? So we can have something like odds is equal to 7, 5, 9, 1, 13, 11, and 3. I understand this is in your slides, guys. I'm coding it so you guys can code along and kind of get that muscle memory of typing in Python. That's the main purpose of this. So just in case you guys feel like it's a little redundant, that's the main reason for this, especially if you guys have never touched Python in your life. We have events. We can do, it's going to be 8, 4, 10, 6, and 2. And then we can print out the result of what min and max will give us. All right, so they're built-in methods or almost like functions, right? So it's gonna have to be used with parentheses. So if you were to be calling min, it would be min, open close parentheses. Same thing with max, open close parentheses, right? In the same fashion that you guys use len, same fashion that you guys use input, as well as print, right? All these are used in this manner. Same thing with min. So we want to get the minimum number within odds. So we wrap odds within our min wrapper, and we can print that out. And we see here it returns 1, which is true. 1 is the lowest number within our list. And then we can also use max. That'll return to us the max number within here. I believe sum should also be here. I think we can use sum. Pretty sure it's a built-in method. Sum should return to you. Print. There we go. Sum, my bad. We return the sum of everything within odds, right? 49. So sum is a nice little method you guys can use as well. Already pre-built for y'all. Now, the next one's gonna be sort, right? Sort will alter the input list and sort it for you. So we can say sort, pass in odds. Okay, that's not gonna work. I forgot why. Oh, it's done this way. Sorted. All right. I'm gonna show it to you what the issue was right now, right? We'll cover sorted first. So we can print odds sorted, right? And it'll return to you the sorted value of this list. But why wasn't sort working? Well, sort is a method you have to call into the variable. So unlike min and max that we started like this, where you did sorted and then open close parentheses and add odds, you actually have to call the value you want. So we'll say odds and then do dot sort. I don't know why they're done this way. Odds dot sort. Okay, we have to save it to a variable. Sorted odds is equal to odds dot sort. And this should be sorted odds. What the heck? What is going on? Why is it giving me none? That's weird. Is anyone seeing something I'm not seeing? That's so weird. I just did that earlier. Anyways, Python doesn't know what it's doing. So here we have odds dot sort, right? Whereas before for sorted, we have to do sorted and then actually add the value we want in here. And it'll sort it for us. But the way these work are slightly different, right? If we do print out how do I want to show this? All right. Let's do odds dot sorts. Actually, no, let's do sorted odds and then print sorted. No, we should be able to do. Yeah. Print odds. Okay. Print odds, odds dot sort, print odds. Okay. So on line 7, we're running the sorted method. We put odds in here, and then we're gonna print odds to see what it gave us. After that, we're gonna do odds dot sort, and then we'll print odds and see how that works. Notice on line 7, we used the sorted method, right? And then we printed it right afterwards, but it's not sorted. It's still its original state. And then on line 9, we use odds dot sort and print it out, and that won't work. But why didn't this one work? Because it doesn't change it. It won't change your list. It's sorted here, but once we get back to line 8, it doesn't have it sorted. Well, why is that? Well, because it didn't change your original list. If we were to print out line 7, it'll show us odds sorted, but it doesn't alter the original list, if that makes sense. It almost shows you like temporarily, hey, this is what it looks like sorted, but it's not actually manipulating your list. Right? So if we were to print line 7, we see here when we do print sorted odds, it's actually sorted. Then we go and print odds just by itself. The original odds, it's not sorted. It never changed, right? But then here on line 9, we use the dot sort method on it and then print just odds. And now it's actually sorted. That is the difference between using sorted or sorts. One will alter your actual list while the other one won't, right? Dot sort will alter it, right? It'll actually sort your entire list. Sorted won't do that. Unless if you actually want to use sorted and keep it sorted, you would have to assign it to a new variable like I did earlier. Sorted odds is equal to sorted odds, right? And then we can print out sorted odds. And now both sorted odds and my original list is actually sorted as well. That's the weird way that sorted and sort work. I know it could be a little confusing. I don't know why they do that. I have to kind of figure out every single time I use them. Just know that they're not the exact same thing, and the way they will react differs, right? So keep that in mind. If your list, whenever you guys are coding, isn't doing what it should be doing, you're probably using sort or sorted wrong. Cool. And we see that here as well on the slides. Sorted will make a copy of the list and sort that. It doesn't alter your original one. Right? Sort will alter the input list and it will sort it for you. All right. Next, list comprehension. This might kind of go over some of your heads. If you guys have never checked out list comprehension, it might be a little confusing to understand it at first, but it's a very powerful tool to use. All right. So list comprehensions are a concise way to construct a new list by applying some transformation to an existing list. Right? It's similar to the map high order function in JavaScript. Essentially, what list comprehension is like creating a for loop within a list. And we can go ahead and kind of type that out. So we have a list here called nums. And it's going to have numbers going from 1 to 5. Right? Originally, if I wanted to manipulate every single number in this list, I would have to loop through, right? I would say for num in nums, I start a for loop, and then I would be able to access every single one. I can go ahead and kind of show you print num. We see printing out 1, 2, 3, 4, 5. Now let's go and do let's go ahead and manipulate these numbers. So we can say for num in nums, num is equal to num times 2. And then let's see how that worked. Print out nums again afterwards. For num, blah, blah, blah. I guess it's not actually altering anything. Let's go and do.
I think you have to print out num. You had NUMS.
Yeah. For num and nums. We'll just print out here instead. Yeah, well, just so you can see how it's being manipulated. Print num times 2. Right, we see here 2, 4, 6, 8, 10. Right, it does something with every single one of them. Now, what if we wanted to do this with less code? Obviously, it's not a lot of code. It's just like 2 liners, right? It comes more into play. There's like a lot more stuff to do. But this comprehension allows you to do the exact same thing by doing something like this. We'll create a variable called double nums, which is essentially going to be a new list, right? We do open and close brackets, and then the way that this is typed down will be in this shape, way, or form. Pretty much what you want to do for your you're like your altering is what you're gonna start off with. So we're gonna say 2 times num for num and nums. Right? Notice that this is the first part of our for loop. And then the actual manipulating of the num goes first, right? So we do 2 times num for num and nums. I know it sounds a little confusing, like what the heck did I just read, right? But notice that it's pretty much the exact same code that we have here on line 3 and 4, just the way that it's typed out, it's different and it's on one line and it's put inside the bracket. We can print out double nums. Right. Notice 2, 4, 6, 8, 10. It actually manipulated the array. I'm sorry, the list. If I wanted to do that and manipulate nums, I would have to create a new list, right? We can call this nums doubled. It's equal to open and close bracket. I would have to do nums doubled dot append num times 2. And then at the end, I can print out nums doubled. Right? Notice that they both do the exact same thing. But here, when I tried to manipulate the list itself, it didn't allow me to. I had to create a second list and which I do it from there and then push it manually. Here I did create a second list, but I didn't have to push anything. Right? I did all the actual logic within the list that I'm creating. So the exact same thing that we're doing here, just 2 different ways of doing it. And in this manner is called list comprehension. And then we can even do conditions. So we saw this, which created double nums. What if we did only evens, right? And notice on the syntax, we're gonna do num for num and nums, right? Same thing here for num and nums, right? We're not manipulating anything on the number, right? We're grabbing it, but we're not doing anything. But essentially, this is going to add every single number within the original nums array, right? Because we're looping through the nums array, and we're grabbing every single one. And because it's within this bracket, that's the numbers that are going to be in here. But they add a condition. If num modulus 2 is equal to 0. So what this is saying is, I want to grab every single number within the nums list, right? Loop through the nums list, grab me every single number, only if modulus 2 is equal to 0. So only if you grab that number, you divide it by 2 and you get a remainder of 0. Therefore, only leaving you with the evens. And we see that here, 2 and 4, right? Because when it does num for num and nums, right? It starts the for loop right here. Num and nums. Here's where we actually do the manipulating of the num itself, but we didn't do any manipulating. But by starting the for loop within this bracket, I'm adding the numbers in here. It's gonna loop through and add every single number within here. But then we also add the condition to the right of it. Condition being whether it's even or not. Right? Do I have any questions on list comprehension? I know this is a little confusing one compared to the other method that we talked about. Okay. All right, we will continue moving on. Next, dictionaries, right? A very powerful data type, right? Dictionaries. My favorite, if you guys recall the conversation for JavaScript, when we talked about objects, there are literal objects and callable objects, right? The ones that we use were literal objects in JavaScript, where it was like your JSON, right? Your JavaScript object notation. You use key value pairs, right? In Python, we call that dictionaries. I don't know why everyone does their own thing and calls things differently. I wish they just came together and just figured out their lives, right? But in Python, it's dictionaries. So a data structure that allows you to store key value pairs, right? One of the most useful data structures in algorithm challenges. All keys in a dictionary in Python must be immutable, right? On top of that, they are unique, right? You cannot have the same key somewhere else. The keys are unique. The values can be the exact same thing. It don't matter, but the keys are unique, right? So we're gonna go ahead and create our first dictionary in Python. It's gonna be called state capitals. To initiate a dictionary, you use your curly brackets. This is the first time you guys are using curly brackets here, right, in Python. That is to initiate or instantiate your actual dictionary. Just like in JavaScript, you have your key and your value. The key here is going to be Washington for the first one, and the value is going to be Olympia. I don't know if that actually is the capital. I've never been there. I failed history. All right. Next one's going to be Oregon. It's going to be Salem. Then we can use Idaho. Give it Boise. I don't know if that's what it was. Then finally Montana. Give it Helena. Anyone from Montana? Good. Ain't nobody know Montana anyways. Oh, Justin, my bad. All right, so here's our first dictionary, right? Notice key value pairs, right? They're all unique for the keys. After every key value pair, add a comma to separate the next one, right? Now, accessing our dictionaries. We're going to print out. To access your dictionary, you're going to call your dictionary by its name. So we're going to say state capitals, and then we're going to use bracket notation, right? Bracket notation. We can say within here, we can add Washington. And you're going to notice it's going to print out Olympia, right? So by calling the key within the brackets, it'll give you the value. I'm a little rusty right now. Let me just double check. They should not work. I knew it wasn't going to work. All right. All right. So state capitals, bracket notation. We grab the, what Washington is. Cool. Being Olympia. Adding and deleting key value pairs. So we've created our dictionary, but obviously everything we want to do, we want to change it. We change our mind. We want to add stuff, delete things from it. If we wanted to add something new to our dictionary, it'll be something as simple as calling the dictionary itself, right? And then just typing out whatever you want the key to be. I'm going to say Texas because I'm from Texas. All right. And then we're going to assign it Austin. Right? Texas and Austin, you literally just start typing out as if like the key already existed and you just assign it the value itself. And then we can print this bad boy out. My mistake. What did I do wrong? Why is this freaking out? Expected parameter name. What? I gave it to you. Oh, probably because I have to. Are you serious? My bad. It won't let me print it out when I assign it. State capitals. Let's go ahead and do it here. There we go. So we print out Austin, right? It added it effectively. Shoot, we can even print out the entire dictionary, but we'll talk about that in a bit. Actually, we'll just print out itself. We can do print state capitals. And then we see here, Washington, Olympia, Oregon, Salem, Idaho, Boise, Montana, Helena, Texas, Austin. It gets added, right? Next, I decide I don't like Montana. I'm gonna delete Montana. So I'm gonna use del for delete, call the dictionary and what key and value I'm trying to delete. Delete Montana. Go ahead and print out our state capitals again. And we see just as before, we printed out Washington, gave it the capital. We added Austin and Texas. We printed out, it's here. And then on the second one, we deleted Montana. Notice Texas is still in here, but Montana is nowhere to be seen, right? So deleting items from a dictionary using the del method. Cool. Next, iterating over dictionaries, right? Very similar to how we iterate for our list, but some small differences. Let's get rid of this print statement for Washington. Same thing for Austin and Montana. All right. So if we wanted to loop through a dictionary, we would start with our for loop. We could say for, and then typically you wanted to give it some kind of name of what you're trying to do. We'll use key for this one. It would make sense to say for state in state capitals, but we'll use keys for key in state capitals, and then we're gonna do dot keys, right? Dot keys, and then print out the key itself. And notice it's gonna print out just the keys, all right? Because we use the dot keys method. Now, what if we just print out state capitals dot keys? Well, if you print out state capitals dot keys, it's going to give you a list, right? A list of dictionary keys, right? It is a list of dictionary keys. For key in state capital dot keys returns to you a list of dictionary keys. Therefore, you're able to loop through it and do something with them. If we wanted to print out our values, you're gonna do something very similar to it. For value in state capitals dot values, print values. Print value. And we see that here, the first section is printing out all the keys. It worked. And then after that, we see the capitals, the values being printed out. So both of these work, right? We can still do the same thing for that on the, just like we printed out dot keys, we can print out dot values, and it'll give us something similar to the keys, which is another list of values this time, right? So this returns a list. Notice it does have the dict keys and dict values. It's printing out the actual method and then what it's returning from inside, right? Which is your list. All right. What if we want both the keys and values? Well, we can say for key, comma, values in state capitals dot items. If I'm correct, JavaScript is dot entries, right? For Python, it's going to be dot items, and then we can say print key values. Run this bad boy, and we see it. Washington, Olympia, Oregon, Salem, Idaho, Boise, Texas, Austin. Let's get rid of line 15. There we go. It prints it out in the exact same fashion, right? Key and values. Right? Once again, what do we print out? State capitals the items. Can we do that? Yes, we can. It brings you a list of tuples, right? If you print out dot items, it gives you a list of tuples, right? Each tuple being the key and value itself, non-changeable, right? And we'll talk about tuples later. Actually, probably in the next slide. All right. One thing I want to cover before I move on, something about looping through stuff that doesn't, looping through using an index, right? What if I wanted to loop this is out of the context of dictionaries. All right, let's go ahead and comment this out. If I had a word is equal to dictionary for letter in dictionary. I'm sorry, for letter in word print letter. It prints out every single letter. What if I want to print out the index of every single item? I can use the enumerate method. Right, enumerate allows you to grab the index of stuff. It can still print out every single letter that you go through when it comes to your word, but you have to add a comma after letter and whatever you want to call the variable, we'll call it index, and we're able to print out the index of every single item that we go through in that word. Enumerate is a nice way to print out the index so you know what index belongs to what item as you loop through, whether it's your word or whether it's a list. Enumerate allows you to do that, print out the index. I just thought to bring that up because that is a nice little method I like to use a lot. Enumerate. Time is 7:34, guys. We're gonna take a 10-minute break. Come back at 7:44. We'll have another hour of class, and I'll leave the last 15 minutes for questions and discussion. And yeah, I'll see you guys in 10 minutes. All right, let's go ahead and come back so we can finish off today's lesson. All right. So next, actually we have like 2 slides and one more assignment, and we should be good to go for the night, if I'm being honest. I don't want to start the next part, which is objects or object-oriented programming, because it's pretty heavy. But we'll go to tuples next. Can you guys see my screen, guys?
Nope, not seeing your screen yet.
Oh, gotta lower my mic. Super loud. But thank you, King. I appreciate it. All right. Last but not least, last subject really, or data member or data type is tuples, right? So they're very similar to lists, right? But they're different in syntax. Unlike lists that are used or instantiated with brackets, tuples are parentheses, right? So they use open and close parentheses. Am I saying that right? Have I been using the word parentheses wrong? These are parentheses, correct? All right. You know when you say a word so many times it loses its meaning? Literally happens to me all the time when I'm teaching. So here we see tuples. The difference between tuples and lists, really, I mentioned to you guys earlier, I believe, is the fact that one is immutable, and one is mutable, as well as the fact the data types too, right? So actually not the data type, I'm getting that confused with race. It's the mutability, right? So once a tuple is set, you can't change it, right? A pro to tuples is that accessing the information inside of tuple, it's actually faster than you would access the information within a list, because of the fact that since it is immutable, it's a preset location. So you can't change it. So it's technically faster to find a location, whereas for lists, they tend to have, the fact that you can move them around can make it a little bit more difficult. All right, so tuples are a bit faster to access, and tuples can also be used as keys in a dictionary because they are immutable. Right. You guys are rarely gonna. I don't want to say rarely. I rarely had to use them for any job I've had. So yeah, they're not too commonly used. Just know that they're a data member you can use. They're mainly used for different things like grid coordinates, like geographic locations. It's helpful in that situation. But I haven't really had too much use of tuples. Just know that you can use them. Mutability and immutability, right? So we've been throwing this word around. So what is it, right? A mutable object can be changed after it's created, and an immutable object can't, right? Some data types are mutable and some are immutable. Pretty much mutable you can change it, immutable you can't, right? We see that here, tuples you can't change it, some names you can change the list, you can change strings, you can change dictionaries, pretty much, right? Now, last one, I know Gary already did it, count letters.py, but this will be the last assignment for today. Let's check that out. Where is it? Count letters, right? I believe it's a fairly simple assignment. You're gonna write a function named count letters that takes as a parameter a string and returns a dictionary that tabulates how many of each letter is in that string. The string can contain characters other than letters, but only the letters should be counted, right? The string could even be the empty string, just open and close quotation marks, right? Lowercase and uppercase versions of a letter should be part of the same count. The keys of the dictionary should be uppercase letters. If a letter does not appear in the string, then it should not get added to the dictionary. For example, if the string is capital A and then lowercase a and then capital B and lowercase b, then the dictionary that returns should contain these key value pairs, right? A having 2 and then B having 2 as well. And no, we haven't covered the is alpha function, so don't use it, Gary. Sound good? Give this a try and then we'll cover it.
Hey Roger, we're not gonna get into the classes and objects today, are we? Muted.
No, we are not. We're just
Okay.
gonna cover this, and then we're gonna call it there. I hate to start a class, cover like 3 slides, and then have to stop. So
Yeah, that's fair. Would you mind if we went into a breakout room just so I can, because I just want to see if there's a better way I could have done this.
sure. Let's see.
I'll go into 3.
Okay, I'll see you in 3. Get close to calling it. I don't know. I think I might just actually start the next lesson. It looks like we still might have a lot of time. So let's talk the count letters, right? So I'm going to go ahead and share my screen. I see a message from somebody. All right. Sounds good, Brandon. Nice time to you, brother. All right, so we're gonna go ahead and move forward. So the count letters. So we have to write a function named count letters that takes as a parameter a string and returns a dictionary that tabulates how many of each letter is in that string. So we're gonna go ahead and define our function. Oh, my keyboard turned off. There we go. Define count letters. It's supposed to take in a string, right? What do you say? Str. Nah, we'll say string. Right. And this string can be anything, right? It could be capital or lowercase letters, and we might even have an empty string, right? Now we are going to declare a dictionary, and this is going to be our amount of letters that we've counted. So we'll just call it letter count is equal to open and close curly brackets. I'll leave it empty. And then we'll set a count to 0. Am I correct? The string contain characters. What do we have to return? Oh, we don't even need a count. It should just be an empty dictionary, if I'm correct. All right, and let's just get some code on here. I'm not reading from any kind of notes or anything. I'm just doing it off the top of my head. The string contain characters for other letters, right? So we're gonna go ahead. We're gonna pre-format our string, right? Because we know that there might be capital letters and lowercase letters, so we can just say formatted string is equal to string dot upper or dot lower, right? And these are methods that strings have. We can go to, I guess we can't. Why can't we? We'll go to W3 Schools, my favorite website. We'll go to Python. We can go to Python strings, right? Modifying strings, maybe even formatting, right? So we have different methods for Python. One of them is being upper, a method that returns a string in uppercase, right? And then we have dot lower, which returns it in all lowercase, right? And that's what we're gonna be using here. We can do dot lower, dot upper. It doesn't really matter. We'll use dot upper here actually because it looks like the example is returned to us a dictionary with these being capital letters. And then we can loop through our string. So for letter and formatted string, and then we're going to check whether this letter is inside of our dictionary, right? So if letter not in letter count, then I want to do something. All right, I want to add it in there. So I will say letter count, open and close brackets. I'm gonna save the letter in here as the key, right? And then I'm going to assign the count of 1. If it's not in there, I'm gonna add it in here and I'm gonna add 1 count, right? Because we've encountered it at least once, obviously, because it's in here now. If we don't encounter it, then we need to. I'm sorry. If we do encounter it, we need to increase the count. There we go. So if the letter's not in there, let's add it in. Set the value to 1. Else, increase it by 1. Right? And then at the end, we should be able to just kind of print out letter count and see how this works. All right. Count letter, and let's add a random string. Nothing crazy here. CD count letters. Python count letters. Okay, string indices must be integers. So what is happening here?
Line 8 needs letter count, right?
Letter count, correct. I had a typo. Thank you. There you go. Thank you, Kim. Appreciate the help. But yeah, so that's how that works. It formatted for us. We have the amount of times that it comes in here. And now we also got the option where it says the string can take. Hold on, my dog's barking. Hey, shh, Oliver, what's wrong with you? I didn't like them outside dogs. Jeez. So essentially, the string can contain characters other than letters, but only the letters should be counted, right? The string can even be the empty string, just open and close parentheses. So what if we had something else? All right, what if we had what's up, buddy? Okay. Baby, can you take care of this? Go to mama. All right, I'm gonna give put you guys on a 2-minute break. My kid wants me to open him a new toy that his mom just got him. 2-minute break. I'm sorry. Duty calls. All right, I'm back. I'm sorry for that interruption. All right, so Samantha, can you take the child, please? So what if we have something else than just letters, right? So right now we only have the alphabet itself, but what if we have numbers? What's gonna happen then? Well, it adds the numbers in here, but we don't want numbers. So how can we take care of this? No, we can't, Amber. If alpha cannot be used, I believe it should be on the instructions.
What was the question? I missed it.
If we have stuff like numbers, right? If we have numbers in here, but we can't use is alpha. It should be somewhere in the instructions here. Where is it at? Okay, here we go. And no, we haven't covered is alpha function. Don't use it. All right, we could use is alpha, but how will we do this if it's not, if we don't have is alpha available to us?
I just do it the way, make a variable that includes every letter in the alphabet. Is there an
Yes.
easier way to do it?
No, that's a pretty simple way of doing it. It's sure it's a little bit of typing. But we could do that, right? We can say alphabet is equal to,
You're not
And
screen
then-
sharing anymore.
oh, I'm so sorry.
And then also, if we do the alphabet thing, then that would account for like punctuation and symbols, right?
It will, right? Whoever has this, drop it in the chat so I don't have to manually type all these letters.
I did it a little bit different. I did if A, I'll put it in the Zoom chat.
What am I doing? A, B, C, D, E, F, G.
You don't have to do each one separate.
You're right. I don't. Love you other than Kim. All right, so we have the alphabet in here: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, O, I, N, T. All right, so we have the alphabet in here. So we might have to do some reformatting here, right? So we format our original string to, well, let's put this inside of here, actually. We format it for it to be upper. And then we check for letter in format string, we check if it's not in letter count, right? But what should we also do? We should probably check if a letter in alphabet, right? If the letter is in the alphabet, then I want to go ahead and look into adding it to my dictionary, right?
I would put letter dot upper though.
Letter dot upper if, where, I'm sorry. It's all
Right where you
upper.
are. Yep. On 7. If you
We-
put if letter on line 7,
We don't have to do that because they're all upper now, right? Format string.
oh, I forgot. Yep, I didn't do that with mine. You're right. Never mind.
It's
Sorry.
okay. It's okay. But yeah, so we, oh no, what happened? Did it break?
I wouldn't put the curly brackets around.
What am I doing? I'm dumb. Let's do, I mean, it could be a list, it could be a string, no matter. But yeah. There we go. Sorry, I'm distracted because my phone just got here and it's loud. So yeah, so now that took care of the fact that we have the 23. All right. It's gonna check whether it's in here or not. It even takes care of the fact if there is a space in here, right? What if we have a space in here? What if this was like D space 23? What does that do? Well, it doesn't count it because it's not in the alphabet, right? Doesn't have it in there. What's another thing that we can take into account? That should honestly be it. Does anybody have any questions? Amber, you did say is alpha. Yes, that is an option. This instruction just said not to use that specifically. That allows you to use something like this, where you would have to check if something is in there or not. So for letter in format string, if letter in alphabet, but that's how that works. Are you guys getting like a nice warm and fuzzy feeling about Python? Are you guys starting to understand it? Is it making more sense? What do you guys like more so far? JavaScript or Python? Be honest.
Python. Hands down.
Definitely Python.
Python, yeah. Kim?
I
can
still like
read it.
JavaScript better because it's what I'm used to. So it'll take me
Yeah.
a while to like Python better. It's just so much easier Python is, but
Yeah.
I'm just brain
It'll
still
grow on
thinks JavaScript right now.
You guys will be using Python for the remainder of foundation programming, and then you'll be using it for like the first month of the immersive program. So you guys will get really good with it. All right. If you're good with JavaScript, know that you'll get comfortable, very comfortable with Python. Just know that that's there for you guys. Now let's look at the next lesson. I'm not going to start it. I'm going to talk about it, right? I don't want to start something and have to leave halfway, and not be able to like finish it. I really bugs my gears. It grinds my gears, as Peter Griffin says. But essentially, I do want to say that concludes our Python crash course, right? That is the entirety of our small little crash course. We covered pretty much all the stuff that you need to know so far. The next part is still technically part of Python, right? But that honestly, it's such a big subject that it's its own lesson, right? But overall, the actual crash course itself was understanding like how to declare the variables, the for loops, the if-else statements, dictionaries, lists, and the different methods, and how that translates from like JavaScript into Python. And utilizing the fact that you guys already know a language like JavaScript that can easily transfer over to something like Python. All right. So that's why I don't know. I'm pretty sure they told you guys when you guys do the assessment, doesn't matter what you do the assessment in, whether it's Python or JavaScript, it should have been available to you guys to do it in whatever language you want. But because you're going to learn both of them anyway, so it does not really matter. But that's the Python crash course. If you guys would like more info for Python, I do have the Python, I'm pretty sure it's actually called Python crash course book in PDF format, and I will be sending that to you guys either tonight or tomorrow via the Slack channel. Don't sell it and try to make a profit out of it. It's like the second edition. I believe there should be a third edition, but if I'm being completely honest with you, there's nothing really that has changed. There might be like a handful of methods that probably became outdated and aren't used anymore, or they're probably changing how they're called, but Python doesn't change too much as they come out with updates. So it's still very relevant, even though it is only the second edition. It should have everything you need to use. It'll even tell you what edition of Python it is, what version it is when you guys start going through it, so you're aware. But everything in there, for the most part, I would say like 98% of the book is relevant still. And it's great. It'll start you off from like bare nothing to creating games and creating like a chessboard at the end of it. But it's cool. So that's a nice kind of book, kind of like a Bible for Python. If you guys like to have, you guys want to go buy it. I've seen it in Barnes and Noble, the most recent version. It's a really good book if you ever need to pull something up and like, oh, I forgot how to do this in Python. Just go through it and check it out, or just use your browser. Also, ChatGPT, who's been using it? I know you guys have. Very helpful, right? I know you guys use it because you guys think we don't know. Your assessment shows us that you guys use it, or at least AI generates stuff. Like we know, right? To a certain extent, we provide some leniency, right? Unless the entire code base is like just copy and paste, obviously. But we know when stuff is AI generated. But when it comes to ChatGPT, guys, I'm sure you guys have already heard conversations about ChatGPT and not only like its different versions and sisters and brothers that other companies have created their own versions of stuff. Just AI in general. ChatGPT is like a double-edged sword, right? Although it can be useful, I like it using it in the manner as instead of doing a Google search, I just ask ChatGPT. It'll answer quick, straight up questions, right? For example, let's say Kim, you forget how to declare a function. If you were to ask ChatGPT real quick, how do I declare a function in Python? It'll show you how, right? Whereas if you go to Google, you have to go to a website like W2 Schools or go to the Python documents and then look for the tab itself and then find it, right? ChatGPT, AI in general, helps you find the answer quickly so you save time and you don't have to rummage through different websites. What I don't recommend using ChatGPT is trying to copy and paste your entire code and then tell it figure it out for me or why is it not working. Can it help? Yes, it might find some errors. But more times than not, it's giving me wrong code. It contradicts itself. And sometimes it might even give you code that is out of scope to what you guys know right now. Right? It'll give you solutions that you probably won't understand yet, or they're gonna be a little too complex for you guys at this level. So use it and take its input with a grain of salt. Funny thing actually, ChatGPT had just kind of started up when I was going to the immersive program. And I don't know if you guys recall, I was telling you guys how I was doing my assessment. I was completely lost on Sunday nights. I had to redo everything because a TA helped me and I deleted like 50% of it. Right. I was failing like most of my tests, right? It wasn't passing any tests, but my issue wasn't the fact that I didn't know how to code. My issue was like I didn't understand what the tests were asking of me. What do they need? So I wasn't asking for answers, but I was asking ChatGPT, like I was giving it a copy of what the test was saying, like the error messages, like what is this error message saying? Like what am I doing wrong? And it was pretty much telling me like, oh, you're failing this because of this, right? If you want to pass this test, change the test case to this so you can pass the test. Like, but you can't do that. That defeats the purpose of the test case. Like, why would I change the test case? Like, obviously, my code is the issue. Like, I'm trying to pass these tests because the test is testing for it to work. But ChatGPT was telling me like, just change the test case to work towards your code. Like, that's not how this works, ChatGPT. So completely useless, right? And that's how ChatGPT can kind of like bite you in the ass, and it might not actually work when you need it to. So use it with a grain of salt. Take its input with a grain of salt and use it carefully. Don't just believe everything that comes out of ChatGPT. I'm sure you guys seen the articles. I'm sure you guys heard about the lawyer who used ChatGPT for his cases, and then they found out, and actually some of the cases that ChatGPT was stating were wrong and incorrect, or never even happened. So like that person lost their license, right? So ChatGPT, it can be helpful, but it can also, mess you up significantly. It can even make things worse. I just wanted to give that quick disclaimer on AI. You will have a class on AI in the immersive program and how to get better with using ChatGPT. Just using AI in general. I think you guys will actually create a small, like, you'll have a machine learning class as well. You'll create something small similar to ChatGPT, which is nice. I didn't have that when I went through. I wish I had it. That's pretty cool because ChatGPT was just coming out when I was going through. But
Roger, can I share something I use ChatGPT for that I find extremely helpful?
Sure, by all means, go ahead.
There's a skill I feel like I don't really know how to use this very well. I'll say, can you create a challenge for me to practice this skill? And it'll keep creating a challenge after challenge after challenge so I can hit it hard. Otherwise, if you do code words, you can kind of pick and choose, but not, it'll give me the exact kind of challenges to practice what I want to get better at.
Yeah, it's amazing. And you can get better at asking it these questions by, it's called prompt engineering, right? So you can look it up, how to, properly engineer a prompt to speak to ChatGPT. Because usually how you ask ChatGPT to do something, that will dictate the kind of stuff that comes out of it. It might be good or it might be trash. So getting good at how to speak to it and ask it for things, I think can do stuff like that for you. But yeah, so we're gonna go ahead and kind of close off today's class. Lesson 8, I'm not gonna get into it. I don't want to stop it halfway when just cover 2 or 3 slides. So we'll just leave it at that. If you guys have any questions, feel free to direct message me. Any questions you guys might have about Python, I will send out that the PDF into the Slack channel either tonight or tomorrow morning. Yeah, I hope you guys enjoyed your Python crash course. And tomorrow we're gonna hit classes and objects hard. So I look forward to it. You guys have any questions for me? If not, you guys are free to go. And y'all have a good night.